Good day and a very warm welcome to everyone joining us for this presentation today. We are going to chat about a framework for road freight decarbonisation, specifically in the South African environment. If we look at CO2 metric tons per capita, South Africa is sitting at 9.98 metric tons per capita, which is quite high relatively to the number of population we have, which is 55.7 since 2014. We are above China, which is 7.5, and also above United Kingdom, which is 6.5. Relatively then to the population, we are emitting quite a large amount of CO2 metric tons per our capita. When we focus on road transportation in South Africa, we see that 43,000 kilotons of emissions are only contributed in the transport industry. From that, 22,000 kilotons are only from total passenger. If you take the passenger away from the total transport, we get 21,000 kilotons, which is only emitted from our freight. Other freight includes agriculture and pipeline, which is 4.2 thousand kilotons, and then you roughly get an estimate of 16.8 thousand kilotons, which is purely our road freight emissions. Now, road transportation in South Africa is the second largest generator of carbon emissions, so this is something we wanted to focus on and to develop something to assist South Africa in decreasing this high amount of carbon emissions that's being emitted from the road freight industry. We then had some key research questions that we wanted to ask and also answer, which was how can we decrease carbon emissions for the road freight industry? What methods currently exist to decrease carbon emissions, and what specifically can be done in South Africa? We then had research problems, aims, objectives, and some of them included to investigate all or some global road freight decarbonisation methods, and then to choose a method to be adapted in the South African environment. We also wanted to address any gaps or opportunities that exist in that current framework or method, and then apply it to South Africa to include those gaps and opportunities. We wanted to quantify the carbon emissions in South Africa for those gaps and opportunities, and then we also wanted to include those in the new method that we chose. Our research approach then was basically three phases. The first phase was to choose a method to apply in the South African market, and this involves secondary qualitative and quantitative data, which consisted of some literature reviews and also research articles. Our second phase was then to quantify the method that was chosen, and this was done by primary qualitative and quantitative data through interviews and questionnaires. And then the third phase was then to develop this new framework by soliciting the inputs from phase 1 and phase 2. So we sent out over 4,200 questionnaires to road freight transportation companies that specialize in road freight. Over 170 requests for personal interviews were sent out, and we investigated over 10 methods to how to reduce carbon emissions for road freight. We used data triangulation to really make sure that the data that we gather is firm and correct and really replicates what is happening in the transportation road freight industry in South Africa. And then we used appropriate statistical analysis to derive any outcomes from the data. During the interviews and questionnaires, we saw some themes that really caught our eye regarding road freight, and this was participants really commenting on intermodal transport and infrastructure, which is not at its best in South Africa. CO2 and pollution was quite mentioned, something that frequently in the interviews. Waiting and idle times, compliance and regulation, empty loading, these are all themes that we could see developed during the personal interviews. We also asked detailed questions in the questionnaires, such as, is sustainability important for the company? Are the employees trained on what is sustainability and how to drive better? Are there any modal splits that are being used? And also if carbon tax was a concern for the participants. So this is quite a very high level summary The detail of this is available in the published works. So after the interviews and questionnaires and the phase one, where we actually chose a method, we saw that McKinnon's framework was really something that was something that had all the different aspects of carbon emissions already included. So this was the framework we chose to apply in the South African environment. So when we did the interviews and questionnaires, we saw four key themes and decision influences emerging, and that was choosing what type of model you are going to use, which was road versus rail, the logistical network efficiency, which was empty loading, which McKinnon already added in his framework, and something which was new to South Africa. We saw that delivery adherence and unnecessary trips was something that could be added to the logistical network efficiency. Operational efficiency, McKinnon highlighted mechanical and behavior. And then we added culture of compliance, which was a fourth new decision influence, which really contributed to RTMS theft and hijacking. Now, these four influences was really key for us driving forward in developing a new framework for South Africa. The development of the framework then attributed to these four decisions, which was the road and rail. We added these new four decisions within the framework. And you can see where it fits into the McKinnon framework, where road and rail is really the first decision that you make before you transport. The second decision, which will be how efficient you transport your goods in the logistical network efficiency. And then also operational efficiency, which contributes to the driving behavior, the vehicle maintenance and the technology. And then the fourth decision, which we included, which is something new, for the McKinnon framework, was the culture of compliance, and this really attributed to RTMS theft and hijacking, which we saw was main influences and levers that you can pull within the South African environment. We wanted to really synchronize all the efforts throughout all the questionnaires and interviews and solicit that into a new framework to make sure that we are touching all the key sore points in South Africa that are contributing to carbon emissions. We then went on to the data questionnaires. Now that we had our framework, we wanted to quantify it. We had identified our gaps and opportunities. So how do we now quantify, okay, what are the main contributors of carbon emissions from these gaps and opportunities that we identified? We then sent out those over 4,200 questionnaires, and we had a return rate of 132 road freight companies that came back with completed questionnaires. You will see that the bulk of the questionnaires were from bulk carriers, and that's 58%, but we really tried and made the data a bit easier for deductions. So we had our bulk carriers, which was palletized bulk, rubble removal, electronics, household furniture, hazardous materials, container transport. So we grouped all of these together in bulk carriers. And then we also had abnormal loads, which was engineering, very large, bulky and clunky materials being moved around. We had our fuel carriers, which is petrol, diesel and coal, fuel and beverages, which really specialized in moving grains and liquidized bulk and also livestock. We had our retail and FMCG, which was clothing, any perishables and non-perishable consumables. And then also our couriers, and also finally some refrigeration trucks, which only specialize in moving refrigerated items. So from those questionnaires, we then actually went ahead and quantified those key decision-making influences. The first was modal shift, so how much of road freight can we shift to rail, and that attributed to 7.5%. We then asked our logistical network efficiency, by how much can we reduce carbon emissions and road freight kilometers if we adhere to our loading adherences a bit better, and that was 7%. Unnecessary trips, so this is driving up and down, perhaps visiting friends with the truck, or missing your slot and you had to go back again to the warehouse or back to the customers, that's 9%. Empty loading contributed to 11%. operational efficiency, we saw that 15% of is contribute to carbon emissions for how the drivers actually drive on the road. So that's harsh braking and acceleration. Mechanical efficiency contributed to 5%, and then RTMS 18%, with theft 1%, and hijacking coming in the very minute scale of very little carbon emissions can be saved if there was less hijacking. We did see that hijacking was a prominent theme in the interviews, and that can be contributed towards this is a very traumatic event in South Africa. It's sometimes also very violent if a truck gets hijacked, and that is why interviewees generally felt that this was something that needs to be raised during an interview. We also then zoomed into slot time adherence and unnecessary trips, because we felt like this is quite a large, undelved academic area where we're not quite sure what sits in. Why do you miss your slot? Why do you drive up and down unnecessarily? And some of the key questions, we could see some themes evolving again, something like flooding, driver error, incorrect deliveries, roadworks causing them to miss their delivery times, and then also load pull for each roadblock, slow drivers, even strikes, making transporters taking unnecessary trips. Just a call out on this slide as well, we're also busy now currently doing a new academic article on delivery adherence and its causes, so that will be released quite soon. So now that we had quantified our carbon emissions, we know what contributes to the largest part of carbon emissions, be it the rail to road shift, operational efficiency or network efficiency. We knew now what quantifies that specific area of carbon emissions. We wanted then to introduce something new into the carbon emissions, which was synergy. What will happen if you can pull all those levers at once and really try to be the best efficient and effective way to move your freight? So then we introduced the concept of synergy by putting all those levers together. So we quantified if you can move your road to rail, you can decrease carbon emissions by 7.5%. Logistical network efficiency is 27%, and operational efficiency is 20%. Now that is quite in the silos. What can be done to reduce carbon emissions in those different silos? But what can be done if you synchronize all those efforts and you introduce synergy? So 7.5% from modal shift amounted to 1.2 billion kilometers you can reduce, and that's only from shifting all road freight to rail, which is something that can be palletized, and then 1.3 million CO tons could be saved. For logistical network efficiency, we saw a total of 27% of carbon emissions and kilometers can be saved, and that roughly estimated to 4.3 billion kilometers and 4.5 million tons of CO2. Operational efficiency, that contributed to 20% of total carbon emissions that can be reduced. That's 3.2 billion kilometers per year and 3.4 million CO2 tons. Now, to synchronize this was quite complex mathematical sums we did in the background by the help of some powerful Excel sheets. And now to synchronize this means you're shifting your road freight to rail. You're making your logistical activities more efficient. You are making your operational efficiencies more effective, and that's really putting all the levers together at once. And also to note, this is if all road freight companies in South Africa pull all these levers and really try to achieve that reduction in carbon emissions. So then a total percent of 46 could be reduced from carbon emissions and total road freight kilometers. That's a 7.3 billion kilometer reduction and a 7.7 million reduction of carbon emission, which is quite high. So in summary, we developed the first road freight carbon emissions framework for South Africa. It was the first time that you could quantify what activities contribute to that 16.8 thousand kilotons. and we also calculated the carbon spend for these freight activities. We investigated a synergy of reduction, what will happen if you have all these levers that you can pull, and what the total reduction will be of carbon emissions. Now, it's also important to note that yes, you can reduce your carbon emissions, but what's also important is with the operational efficiency will also come a cost reduction. So in battling climate change, I think it's important to note that companies are really driving towards operational efficiency, but also towards a reduction in costs. So I think going forward, this is quite important to bring forward to companies that yes, you can have a reduction in your carbon emissions, while also at the same time have a cost reduction on your bottom line. And that's all from me for now. If you have any other questions or comments, please feel free to submit them to me. I will also be available in the Q&A sessions where you are welcome to reach out to me.